always great to have Dr. Avi Loeb with us. If you don't remember who he is, you have to remember, but let me just give you a reminder. He is the author of Extraterrestrial, a fascinating book that we discussed a few years ago. He followed that up with a wonderful second book, which was called Interstellar, and we're going to learn a little bit about that. Also, the Oumuamua fragment or object that was sighted off of our planet. We discussed a great deal about that. And what we are going to talk about today is also fascinating, but I want to first, before I do that, bring Avi in. Avi, great to see you again. Welcome back to Earth Ancients.
Thanks for having me. In fact, I just signed a contract with MIT Press. I'm working on my next book, which will be about the expedition that we will discuss to retrieve materials from the crash site of the first interstellar meteor.
Wonderful, wonderful. Okay, let's get right into it. This meteor hit the ocean in 2014 in the Pacific Ocean in the New Guinea region of the ocean. So when we left off, you were looking for the funds to do a analysis. You were going to dredge the bottom. Give us the highlights. Let's get into it. What?
Well, first thing is I had a Zoom call with Charles Hoskinson, and he said, you have the money. And that was $1.5 million needed to do the expedition.
$1.5 million to do the dredging.
Yeah, because we had to spend 2 weeks on site. The location was identified by US government sensors as the fireball that released about 1% of the Hiroshima atomic bomb energy when an object roughly half a meter in size collided with Earth at a very high speed. And the reason that it was interesting for us is because this velocity of this object was so large relative to the sun that it was not bound by gravity to the solar system. It came from outside the solar system, and therefore it's the first recognized interstellar meteor. It appeared in a catalog that NASA compiles of meteors that the US government sensors on satellites identify, because the US is trying to monitor any launch of ballistic missiles from the heat that they generate. But every now and then there is an object that produces an explosion. And in fact, every year there is an object the size of a person that collides with Earth and results in an atomic explosion in our atmosphere, basically as much energy as released by the Hiroshima bomb. And we don't talk about it. It doesn't appear in the news because those explosions usually happen at a very high altitude, and they don't damage anything on the ground. And, you know, most of the time they occur above the ocean. 71% of the surface of the Earth is an ocean. But in this case, the object was exploded only 20 kilometers above the ocean surface, and that meant that it was unusually tougher than all other meteors reported in the NASA catalog, hundreds of them. And moreover, even outside the solar system, it was moving at 60 kilometers per second, faster than 95% of the stars in the vicinity of the sun. And so I was wondering whether it's a Voyager-like meteor or, on January 2nd this year, 2025, an amateur astronomer recognized a point of light coming close to Earth and classified it as a near-Earth object, an asteroid. And as soon as that was reported, a few scientists realized, actually, this object has the orbital parameters of the Tesla Roadster car that Elon Musk launched in 2000, a dummy payload on the Falcon Heavy. So it was not an asteroid, it was actually a technological object, a car. And maybe this meteor from a decade ago was also technological, maybe some space trash. So I wanted to check that. So I announced our intention to go on an expedition, and then came the funding. And we had an exceptional team on a ship called the Silver Star.
Let me stop you 1 second, Avi. Can you explain why we should care about what you define as an interstellar object versus just a meteor that we must be bombarded constantly by meteors? This is interstellar, which is a whole different definition. Give us a little background on that.
Right. So never before was an object colliding with Earth identified as coming from outside the solar system.
Right.
Because, we are bombarded by rocks from the main asteroid belt. You know, there is a region of the solar system where there are plenty of rocks left over from the formation of time of the solar system, but also as a result of collisions among various protoplanets. And we see that, in fact, with the Webb telescope very recently, rocks all the way down to 10 meters were identified just from the heat that they emit with the Webb telescope that is extremely sensitive. And so we see this reservoir of rocks in our backyard. It's just like when you own a home, you have a backyard. Sometimes if you're not in a city, and you can find rocks there. So we have that as part of the solar system. These are familiar objects, and they are triggering every now and then a meteor appearance in our sky when they collide with Earth as the Earth moves around the sun. So these are regular occurrences. What was special about this one is the object was moving so fast relative to the sun that it cannot be bound to the solar system. It must have arrived from outside because gravity is not strong enough for the sun to trap it. And so that was the first time we noticed a meteor reported with such a high speed. And I wanted to check whether it's potentially technological in origin. Just imagine Voyager leaving the solar system and eventually colliding with another planet. It would appear as a meteor. So we went there and we used the sled with magnets on both sides. We placed it on the ocean floor, which is about a mile deep at that location. And then we went back and forth 26 times across the region of about 7 miles where the explosion took place. And then we recovered magnetic particles that were very different from the background sand and looked like molten droplets, potentially from a meteor, 850 of them. And I brought the materials back to the laboratory of my colleague at Harvard University, Stein Jacobson, and we also analyzed them at the Bruker Corporation in Berlin with an X-ray fluorescence analyzer. But at any event, in Stein Jacobson's lab, we studied the composition, the chemical composition of those spherules, and we found that 80% of them belong to materials from the solar system that was seen before, but then 20% look different. And then out of those, half have a chemical composition that does not resemble solar system materials. Those are the ones that we flagged as potentially from outside the solar system. They had a very high abundance of beryllium, lanthanum, uranium, and we call them Belau spherules or fragments. And what we are planning to do next, I just met with Stein Jacobson and his research assistant, Eugenia Young, and I received funding for us to continue the work for the next 12 months, where we will look at the isotopes that make those unusual fragments and try to figure out their age, for example, because if we can date them, then we can tell conclusively whether they came from the solar system or outside of the solar system, because any material from another star would have a different age. And the way to tell the age is by using isotopes that decay after some time, and from that you can use them as clocks. So that's what we are planning to do in the coming months. But in addition to that, we want to find bigger fragments, bigger pieces of the original object by having a second expedition. And that will cost $6.5 million, because now we will need to put a robot, a remotely operated vehicle, on the ocean floor with a video feed. You know, previously we did it blindly. We collected materials without seeing what we are collecting. But now we want the robot to actually pick up pieces in the region that look interesting. And so at the moment, I'm seeking funding for this. We need to make a down payment. We have a ship that is ready for us to use in August 2025, but we need to put a down payment of $1 million, and I'm waiting for a funder. Any person that comes forward to fund this could come with us to the expedition site and see what we find. We can give that person priority of being first to see what we are finding.
Oh, they can come along on the ship.
Yes.
Wonderful. Do you have any sense? Of course, it's hard to tell the original dimension of this. I'm just going to call it a probe or a meteor. But what do you suspect? Is this another Oumuamua?
No, it's a smaller object. Oumuamua was a different object that came within a sixth of the Earth-Sun separation. It didn't collide with Earth. It was just passing by, and it was much bigger. It was 100 meters in size and looked very strange because the amount of sunlight that was reflected from it changed by a factor of 10 as it was tumbling. And so the most likely shape that it had was that of a pancake, a flat object, a disk. So that was a different object, also interstellar, because it was moving faster than needed to escape from the sun's gravity. This object, based on the amount of light that it generated in the explosion, we can say that it was at least half a meter in size. Much smaller than Oumuamua, but at least half a meter. We know that half a meter of it evaporated probably during the explosion, but whether it had a bigger core or not, we don't know. For that, we need to go to the site and look at the wreckage there. And, if these kind of sizes are the kind of spacecraft that we launched in the past, if you think about Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, New Horizons, these are spacecraft making their way out of the solar system. And they were roughly in this ballpark of size, of older meters. And therefore, on the other hand, if you think about Oumuamua, that was bigger than even Starship, the biggest rocket that we are planning to use. And so what Oumuamua was is still unresolved. I tend to think that it may have been, for example, an empty trash bag object, like a very thin film that maybe was torn apart from a bigger structure. Maybe it's a broken piece of some megastructure, like a Dyson sphere that will break up if the star that it surrounds evolves and eventually breaks it apart. So to me, Oumuamua could have been space trash from another civilization, but their trash is our treasure. It will tell us something important. So actually, it's very difficult to observe Oumuamua any longer because it's already very far away. But there will be a new observatory in Chile called the Rubin Observatory that will employ a camera with 3.2 gigapixels this year and will start to survey the southern sky every 4 nights. And it could find an Oumuamua-like object every few months, given its sensitivity. So I very much look forward to finding family members of Oumuamua. You see, the point is, mainstream scientists can deny that Oumuamua was weird. They keep saying it's a rock of a type that we've never seen before. Or they say, maybe it's a dark comet. A comet that we can't see the cometary tail of. So it was propelled just by a cometary tail that is invisible. But once we have good enough data about another object like Oumuamua, and we can look at it with the Webb telescope, once we have a lot of data, it should be impossible to imagine things that don't exist. If it looks different than a rock, we will know it. And that's what I want to find out with the Rubin Observatory data that will come soon.
Why, though, your colleagues have such a problem with the possibilities of these being a ET probe? Why is it? I mean, this is getting out of hand, Avi, and we're not even talking about UAPs, which we actually see. We're talking about these perhaps probes that, according to you, could be 1 billion years old.
Right. Well, it's because the significance of finding something like that would be great. And when I came up with this suggestion about Oumuamua, there was a lot of attention from the public, from the media. And in academia, the strongest force is jealousy. So when people see a lot of attention, they try to step on it, suppress it, say bad things about whoever talks about it. It's basically out of jealousy. They want the attention to themselves. They don't want anyone to pay attention to what someone else is talking about. That's the first order reason for why there is a lot of pushback. It's basically jealousy for the attention. But the other thing is that, it's risky to talk about something new. It's much safer to talk about things that everyone talked about in the past. So you would rather, as an expert, quote unquote, you would rather say that anything in the sky must be a rock rather than an extraterrestrial technological gadget, because you're taking a risk if you were to consider that. But I should say that even the telescope that discovered Oumuamua, a few years later, it found another object that was pushed by reflecting sunlight, and that ended up being a rocket booster from 1966. It's called SO. And so it found a technological object that NASA produced. And Originally thought maybe it is a comet or a dark comet. So I think we should take it with a grain of salt. And what happens in the mainstream is that experts always want to argue that there is nothing new, that everything we see represents their past knowledge, because that's the way they maintain their stature in the field. Imagine if there is space trash from other civilizations out there, and what they call dark comets will end up being technological artifacts. Obviously, it will be embarrassing for them. So they will try to resist it as much as possible. And, this is not new, because yesterday, actually, we had a very interesting event, celebration of art and science in my office at Harvard. One of the most accomplished sculptors in the United States, his name is Greg Wyatt, created a sculpture of Galileo Galilei looking at the 4 moons of Jupiter. That's what convinced Galileo that the Earth is not at the center of the universe, because the moons are orbiting Jupiter, not the Earth. And so he just made a sculpture, Greg Wyatt, and he brought it to my office. He donated it to me. And we had a beautiful event in which we also had a historian of science talk about the life and research of Galileo Galilei. Her name is Hannah Marcus, and she's a professor in history of science. And she described how many difficulties Galileo had proposing this. And, in 1992, the Vatican admitted that Galileo was right. That was 2 decades after we reached the moon. And it's a bit late in 1992, more than 350 years after the death of Galileo, to admit that he was right. So, you can see it across the history of science many times, over and over again, that ideas that turned out to be right were resisted very strongly by the mainstream at the time, simply because they represented new knowledge. But the good news about physics is that it relies on evidence, on data. It's a learning experience, and we should be humble to pay attention to anomalies. We should not dismiss them the way the experts, quote unquote, are doing. We should look at anomalies because it's an opportunity to learn something new. That's all I'm saying. But in answer to your question, it's a very common occurrence in the history of science for those that propose new ideas to get rebuffed and even get personal attacks. At least I'm not in house arrest, the way Galileo was.
Well, I wanted to mention that because when we first talked, you said that you refused to sign a non-disclosure agreement. I think it was with the Department of Defense. This is many, many years ago when you started your work. And I would think that as a scientist, if you find exotic metals from this fragment, that would be something that people would be rejoicing,
Right. Well, I should say that I also initiated the Galileo Project. I'm leading a Galileo Project at Harvard University. We built an observatory that looks at unidentified anomalous phenomena, basically monitoring the entire sky in the infrared, optical, radio, and audio. And we already published a report about 500,000 objects in the first 5 months of the operation of this. This is the commissioning data. And we are using machine learning software, artificial intelligence, to analyze the data and look for any objects that are not familiar, that are different than drones, balloons, airplanes, things we know about, satellites. And now I received funding to build 2 additional observatories, one in Pennsylvania and the second one in Nevada. So altogether, by summer 2025, we'll have 3 observatories operating, and we will get data on millions of objects in the sky. And even if 1 in a million happens to be extraterrestrial, that will be big news. Now, of course, it's possible the US government has already some data and the materials. There were testimonies in front of the US Congress about it. I would actually love to know about it because it will save me time. But my point is that, the sky is not classified, the oceans are not classified, and astronomers have been looking at the sky for many centuries, so since Galileo, using telescopes. And so we don't need to rely on government regarding what lies outside the solar system. Their day job is national security. Yeah. My day job is to figure out whether we are alone or not, whether there is a partner out there. And, we already know something that previous generations of scientists did not know, like Carl Sagan didn't know that. We know that at least a few percent of the stars in the Milky Way galaxy have a planet the mass of the Earth within the same separation as Earth is from the sun. And that means that there are tens of billions of systems like the Earth and the sun within the Milky Way galaxy alone. And, these systems, if you maintain a humble approach and say that we are not special or unique and things like us could have existed, billions of years ago, just because most of the stars are older than the sun. We know that most of the stars are billions of years older than the sun. So there could have been things like us billions of years ago. And guess what? The Voyager spacecraft in a billion years will be on the other side of the Milky Way galaxy. So there was plenty of time for Voyager-like spacecraft, for space trash, to come to our backyard from the other side of the Milky Way. And they would accumulate, these objects would accumulate just like plastics in the ocean over billions of years, because they're bound by gravity to the Milky Way galaxy.
When you consider, and I think you said 20% of the fragments you picked up from the ocean were unusual, is it your belief that some of these are composites of exotic metals that may have been used for the body of a probe of some kind?
Well, so we found the chemical composition, but it's challenging to say exactly what the origin was. Just imagine taking a laptop and throwing it to a fireplace. You will get molten droplets of unusual composition, but you can't really tell that it was technological in origin until you find bigger pieces. And that's what we aim to do in the next expedition. That's exactly the reason. In order to figure out the nature of the object, we need bigger pieces that were not melted all together, that there is something left from the original object. So that's what we want to find in the next expedition, and for that we need some seed funding right now.
You need some serious funding. So those of you listening, we'll present some details at the end of this interview to see what we can do to help Avi and his research. You mentioned artificial intelligence. Are you able to, or one of your students able to actually program the intelligence to look and diagnose and perhaps retrieve data that you can't find?
Yeah, that's exactly what we are doing, because we have a very large data set and it would take a human a lot of time to go through it. So we are training the AI systems to look for objects that are familiar and label those that are unidentified. And this will be extremely important. Now, one of the frontiers in AI right now is using data from different modalities, different probes. So, for example, the human brain is using data from vision and from audio, and combines it to get a sense of what we see. And that is one of the frontiers right now in AI, combining data from different sensors, different modalities. And we have an acoustic detector, audio. We have infrared, we have optical and radio. So we hope to develop the tools that would allow us to use all of them together. And that's something we are doing right now with a team that works on AI. I should also mention that Elon Musk commented that, humanity needs to go to Mars because we are probably alone. And after the elections, Peter Thiel suggested, he said on a podcast, nobody should bet against Elon Musk. Nobody should bet against Elon. And the following day, I placed a bet against Elon. I put it in an essay on medium.com where I said, look, there are tens of billions of stars with an Earth-like planet next to them, just in the Milky Way galaxy alone, and 1 trillion galaxies in the observable universe and many more beyond the cosmic horizon. I'm willing to bet that something like us existed billions of years ago in the Milky Way galaxy, and I'm willing to put 1% of my net worth forward. If Elon is willing to put 1% of his net worth into a pool of money, that will be $4 billion taking his part, much less from my part, but we can use that money to search for any technological debris that came from another civilization within the orbit of the Earth around the sun. In fact, a week ago, I submitted a paper that describes what kind of a space telescope can find such interstellar objects as they come close to the sun, because the sun is a lamppost that illuminates the darkness of space. And when an object comes close to the sun, we can see it very clearly. So I designed the parameters of a space telescope. It just needs to have less than a meter in size mirror. And if we were to have this bet with Elon, within a decade, I should be able to report whether there are any technological artifacts among all the objects that come into the solar system to our vicinity. And, if we don't find anything, this amount of money of $4 billion is actually less than was invested in the search for dark matter. And we haven't found the nature of dark matter as of yet. Yeah. And I say that the public cares much more about whether we are alone than what is the nature of dark matter. So it makes a lot of sense to put similar amount of money in the search for technological debris, space trash, or even functioning devices. And so I very much hope that this bet will get to the attention of Elon and that he will take me on it, because I know exactly what needs to be done if we have the money.
Yeah, I love that.
And I'm also willing to put another % of my net worth to his account if we don't find anything.
Oh my God. I love that challenge, Avi. I think it's fantastic. When we talked last, you had mentioned that you asked one of your students to go to the DoD charts and he found this 2014 meteor. Will the artificial intelligence, if you program it in such a way, be able to look at those charts and find other interstellar probes that have perhaps come into the atmosphere?
Yeah, so that's exactly what a postdoc of mine is now doing. A postdoc within the Galileo Project that I'm leading develops AI models to identify interstellar objects from the data that will come to our attention from any telescope, including the Rubin Observatory. So he actually is using AI to improve the efficiency of finding such objects, exactly to your point.
Okay, well, that's excellent. I have to ask this, and you already brought it up, Avi. When we have so many of these UAP sightings, unidentified aerial phenomenon sightings, do you even consider or get involved, or does the Galileo Project even have a division that is like, okay, this is very anomalous, we need to look a little closer here?
Yeah, so I'm getting reports from people every day. But in addition to that, for example, there were the reports about the New Jersey drones and about some other interesting sites. And we are basically looking at the information that we receive and deciding whether to send a set of instruments to detect whatever is being claimed, if it looks sufficiently intriguing. As you know, the White House has suggested that the New Jersey drones were human-made and, in fact, fully understood. And so there was nothing unusual about those drones. It didn't come from an adversarial nation, according to an announcement that came from President Trump. But, these drones were also behaving like drones. They were not anomalous in the flight characteristics. So that was not surprising. But there are reports all the time about unidentified anomalous phenomena, and if we have an opportunity to look for them, we will do that.
Okay, so you could adjust your telescopes to actually look at something that's perhaps orbiting the planet?
Well, we have those observatories, the one that we have right now operating at Harvard University, but then 2 others that we will set in Pennsylvania and Nevada. There might be a 4th one in Indiana. I'm communication with people that are willing to fund it. But these are stationary observatories. They are fixed in their location. However, we developed some set of cameras and sensors that we can deploy on a truck or bring with us in a suitcase. And those are the ones that we can, those mobile ones are the ones that we can carry to places that are of great interest.
It's funny. I think of what you're doing, which is analyzing fragments from these meteors. Do you have a protocol to actually look at like impact craters to see if they could have fragments, or even the meteors that we have that we know are metals? That's crazy. Of course, you need a whole team, a whole legion of researchers to support you, but is that a consideration?
Well, that's a very interesting point. But the thing is, right now we use the speed of the object to figure out whether it came from outside the solar system. So if we just have a crater, we can't really tell at what speed the object came, because the size of the crater is dictated by the amount of energy carried by the object, and the energy depends on its mass and its speed. And since we have no knowledge, independent knowledge of the mass of the object, you just know how much energy came in without knowing what was the speed. Because there is this degeneracy. You can trade speed for more mass or vice versa. If we just have craters or meteorites that are recovered, we can't really tell where they came from. However, if we examine, for example, interstellar meteors where we had velocity information, because the US government, for example, monitored them before they hit the Earth, so we know their speed, or after they hit the Earth, in those cases, we know they're interstellar, and we analyze the materials from them, that would allow us to find the fingerprints of interstellar meteors. So once we know what interstellar meteors look like in terms of their structure, composition, then we can go back to all these collections of meteorites and see which meteorites resemble those that we know are interstellar. You see,
This sounds like a future project. It's not
that's a future project. But before getting there, we need to look at the ones that we have velocity information about, and like the meteor from 2014 that we went after. So that's why this work is important, because if we find the fingerprints of interstellar, we will then look for those fingerprints among the meteorites for which we don't know the velocity. The speed.
Is your theory that it's simply space junk that you're looking for, or are you going out and on a little bit of a limb and saying we are also looking for potential alien probes who are seeking out civilization?
Well, with the observatories that we have, we're looking for objects that are flying in the atmosphere. These need to be functional devices. They cannot be just debris colliding with Earth, because otherwise they will burn up as meteors, okay? And so in the context of interstellar meteors, like the expedition that we took, the assumption is that, if it is technological, it's not functioning. It's not functional anymore. It just collided with Earth. And if you think about the probes that we launched, like Voyager, they will not be functional once Voyager exits from the solar system. It will be in 10,000 years. The equipment will not be working. So it will collide with a planet like the Earth the way that a rock does, except it will be of very different material strength than a rock. It would look like a rock of a type that my colleagues have never seen before. Just like if the Tesla Roadster car were to collide with Earth in 20 million years, which is quite possible, actually, it would look like a rock that was never seen before. And so for those interstellar meteors, that's the approach. But if they don't collide with Earth, then we need to study their composition in a different way.
I gotcha. All right, so you go out, you got your $6 million, you're going out again in August, you dredge the water, you pull up a machine. How does that change our evolution? I think it profoundly changes our understanding if you qualify what you have as a machine, but I'm curious to know what your feelings are about the divulging a machine of an alien origin to Earthlings.
Yeah, so let's think of the Tesla Roadster car as an example. Calculations show that it may collide with Earth in 20 million years. So suppose it were to collide with Earth, it would appear as a meteor, or there will be a fireball, and then whatever remains in the core of that car may sink down to the ocean floor. Now, my colleagues would argue there is nothing unusual about it because it's bound to the solar system. It's probably a rock. It looked a bit strange, but it's just another asteroid. But if there would be in 20 million years a curious scientist that would say, no, I want to check it out because it showed material strength. It actually exploded very low in the atmosphere, and it showed material strength that is much tougher than all rocks. A person would find is the core of the car lying on the ocean floor. Okay, so that is a very clear signature. You can easily say this is a technological object. When people ask me, how would I know? It's very easy. If you find a big piece in the wreckage of that meteorite, then you can tell whether it was a rock or a technological gadget. And the question is, if it's a gadget and it has buttons on it, should we press a button?
I love it. But let's stretch our minds a little bit more, Avi. I believe that when we know we are not the only ones in our cosmos, we automatically have to look at our human lives much differently. But how do you feel about that?
Oh, yeah, I think it's really urgent for us to find alien intelligence. Right now, we are focused on artificial intelligence as the next big thing because it might actually become much more capable than the human brain, within the next decade. But AI is not just artificial intelligence, it could be alien intelligence. And in that case, it could also be much more advanced and than us, than the human brain. And so we have an opportunity to realize that there is something smarter than us, and that would be a big revelation for humanity because it will give us a sense of humility. Right now, we think of ourselves as at the top of the food chain. We eat animals that are lower in the food chain in restaurants, and we don't have any evidence for something smarter than us, but AI will bring it here. And if it comes from another star, I think it will serve the same purpose as, the Messiah in religious texts. The idea is that there might be peace and prosperity brought to earth by a messianic future. And the way I see it is that we would realize that there is a smarter kid on our block because they were able to arrive to our doorstep before we arrive to their doorstep. And that will change everything because it may inspire us to think more broadly rather than engage in conflicts on this earth. We're spending $2.4 trillion every year on military budgets worldwide, and we could have invested the same amount of money instead of trying to kill other people or prevent other people from killing us. We could have invested it in exploring space. And so I hope it will bring us to our senses. We would realize we are all, in the same boat, the Earth, and we should cooperate rather than fight each other. Realizing there is someone else, a neighbor out there, will change everything. When my daughters were young, they thought that they are at the center of the universe because we paid a lot of attention to them. They haven't met other people at the beginning. But then when they looked through the window, they would see other houses on the street. But if you were to ask them, they would insist that there is probably nothing worth as much attention as they deserve because they got all the attention at home. That's exactly the status that my colleagues, astrobiologists, are at. They think that it's an extraordinary claim to imagine something like humans, something as smart as we are out there, even though we know of many houses in our cosmic street that look just like ours. I realized that when my daughters went on the first day to the kindergarten, they had a psychological shock, but it was important for them to mature by realizing there are many other kids like them and some of them are smarter. They learned from that experience. So we are still in the early phase where we haven't matured yet. We think it's an extraordinary claim that requires extraordinary evidence. I say no. There must have been things like us many billions of years ago, and that's the most likely assumption. And in fact, it's an ordinary claim to imagine something like us. It's presumptuous, it's arrogant to think otherwise, and we just need to find ordinary evidence for this ordinary claim. But the problem right now is there is no funding from federal agencies to look for extraterrestrial intelligence, and I think it's just inappropriate. I think this is a subject the public cares about, the taxpayers care about. It's a matter of common sense to imagine something like us elsewhere, within the Milky Way galaxy. So let's just search for any artifacts that they may have sent in the vicinity of Earth. And it doesn't need just to be in the form of UAP, unidentified anomalous phenomena. It could be also in the form of space trash that is flying around, and every now and then the Earth collides with one of them.
That's amazing. Do you believe are we still using radio telescopes?
Yes.
Okay. Do you think that we could find somebody to really dial in the AI to find an ET civilization with?
Yeah, so this is the traditional method looking for radio signals that has been, used over the past almost 70 years. We haven't found signals that indicate an artificial origin. It's just like waiting for a phone call at home. Nobody may call you when you're waiting if you're waiting for a short time. I mean, we've been searching for less than a century, and maybe a signal was sent 1 million years ago. It's now 1 million light years away. We would not detect it. So yes, To answer your question, AI can be very helpful. And in fact, it's being used right now to analyze radio signals from the best radio telescopes on Earth. But so far, we haven't found any signal. I'm not surprised. I think it makes much more sense to look for packages in our mailbox or in our backyard. A tennis ball that was thrown by a neighbor that may have arrived, or an empty trash bag from a neighbor. These kinds of things may be out there. We haven't searched for those things, and we should do it.
Yeah, it doesn't sound like you're a fan of the Frank Drake hypothesis of sending out and see if somebody or picking up a signal from a distant planet.
Well, it's just that we've tried that. And, Albert Einstein said, if you keep doing the same thing over and over again, expecting a different result, then you're probably not smart.
As we conclude, Avi, and it's always fun speaking with you, what in the perfect world that you are in would be an ideal scenario for you in recovery?
So it depends what we find. I mean, if it's at the bottom of the Pacific Ocean, we can bring it up, examine it. That would be amazing if we were to find a piece of a technological gadget that is not human-made. However, even if we see something at a distance, just as a result of it coming close to the sun, and then if it comes within the orbit of Mercury, for example, such an object will heat up to more than 600 degrees, and we would see it glowing. And in fact, it may get evaporated, so we can analyze the material that comes off it from a distance. We can do it remotely. That's my idea about the space telescope. And so we can actually study objects that come close to the sun, get very hot, and emit a lot of radiation. They also reflect a lot of radiation from the lamppost, the sun. The sun is very useful as a lamppost, and we haven't used it for that purpose as of yet in terms of finding interstellar objects that come close to it. And I'm suggesting let's look for the keys under the lamppost.
Exactly. Would you have to have permission if you found a technological object in one of your dredges? Would you seek permission before releasing it to the public?
Well, first I want to understand what it is before doing anything. In principle, the way science operated in the past is that if you go to a site of a meteor and you find the remnants of the meteor, and if it doesn't lie within the territorial boundaries of a nation, then in principle, you can bring it to a laboratory and study it. That's what happened with meteorites before. This is a very unusual scenario where the meteorite may not be a rock. But if it happens outside the territorial boundaries of countries, then it's available for science to examine. If it's within the jurisdiction of a country, then you need to get permission to take it out of there.
So if you were dredging off a New Guinea island and you found a piece of a technological object, you would need to get permission from them to take it back to the United States?
Well, no, the site that we're talking about of the meteor from 2014 was outside the territorial waters of Papua New Guinea.
Oh, it was. Okay.
But at any event, if we go there again, we are collaborating with the university at Papua New Guinea. And as a result, it is called the UNITEC. So it will be done in cooperation with the local authorities, with the university, and we will do it in partnership with members of that university.
Yeah, that sounds like a collaborative type of discovery, which is wonderful. Dr. Avi Loeb, always a pleasure to have you on the program. Give us a sense of Tell us where people can read more about you. Give us your website. And if you're starting a GoFundMe for this next exploration and where people can donate.
So I would recommend checking Avi Loeb at medium.com. I put essays every day or two about the latest updates, about interesting news in space science, astrophysics, the search for intelligent life, AI. And we have also the Galileo Project website where we have a button saying donate to us. But if we are talking about a significant contribution, for example, towards the expedition, the person can contact me directly. And then there will be a Netflix film coming out within a year.
Oh my God.
That will feature the expedition. They were with me over there, and will include the footage. In fact, they were with me yesterday, and it should be quite exciting to watch. And of course, there are papers that came out from the expedition, from the Galileo Project, that one can find on the Galileo Project website. So there is a lot of materials out there about the work we're doing, and I'm very excited about this year. I think we may be up to something.
I hope that your wish is granted and you find a technological object in your next sweep.
Thank you. By the way, there is already a TED Talk that I gave in 2024. It was ranked number 5 in popularity among all TED Talks. So if anyone wants to see a summary, 20-minute, 18-minute summary of what we found so far, check it out.
And by the way, I saw that it's a very excellent TED Talk. It was July of last year. It's called My Search for Proof Aliens Exist. And it's very well done, had a full crowd, and it was a standing ovation. So obviously people were inspired as much as we all are. Avi, fantastic. Much success on this new venture. Let's have you back on the program after perhaps early next year or late this year. And by the way, when's the new book coming out? Or are you still working on it?
Within a year, it should be delivered to the press. And so I assume in 2026 it will come out. I'm not sure exactly which month, but we should be finished with it by the end of 2025.
Wow, you have so much energy. It's amazing. It's wonderful. All
well,
right.
In life, I realize it's always good to be optimistic because life is sometimes self-fulfilling prophecy. So if you're optimistic, good things will happen.
Yeah, I like it because you're very transparent about what you're doing. I think there's so much that is hidden. If the government does have evidence of extraterrestrial craft, we'll never know about it because they're paranoid. They don't want people to know about that. So, and I really appreciate your openness in your work, Avi. So thank you very much.
The Vatican tried to suppress what Galileo saw, but eventually it admitted that Galileo was right. So I have hope that if the evidence is out there, we will all know about it eventually.
Fantastic. Great talking with you as always. And we look forward to speaking with you again.
Thanks for having me.